So as I'm fixing everybody's attendance, we are going to go through and talk about a couple of um, things that we have coming up, as well as basically the schedule for the next few days. Okay, so the um, goal for us is going to be to make sure that we have a decent understanding of all the Unit 2 concepts and basically closing out Unit 2 by Monday. Okay, so and I did this for second period as well. One of the things that um, you guys you guys are um, not that familiar with is how to get to where we are. Okay, and so what I want to show you is, first of all, here's your reference table, okay, which you'll use for your bore model and things like that, and the YouTube channel, which obviously you know. But we're in Unit 2. So the way that you can get to Unit 2 is if you click that Enter Here button and click Unit 2. This is, sometimes you guys probably see this screen as I'm going through different pages and stuff. Okay, but this is every day. Okay, and these check for understandings aren't active. We do some of them and not others, but it's every day. Okay, with the lesson for the day. All right, so that's a good reference for you to see what we've been doing, and a good reference for you to, um, you know, kind of have a decent understanding of what's going on. Okay, and when we um, look at this, when we look at this, we're going to kind of go through and talk about a little bit of um, what we have tomorrow and Friday as well as Monday. Okay, but the main thing is, okay, we're going to have this stuff in our page tomorrow. Okay, but the Unit 2 study guide, the Unit 2 binder check is basically going to be something that's coming up, and it's on this page here. Okay, now so the goal for us is to kind of understand what it is that we're doing and how we have stuff coming up. All right, and so today we are going to be doing noble gas configuration. Okay, which is basically electron configuration continued. Okay, it's the second part of our electron configuration stuff. Okay, tomorrow, what's tomorrow? Thursday. We will be doing the last thing that we need to be working on, which is the orbital diagrams. Okay, which is built upon the stuff that we've been doing. Okay, and Friday will be a combination of review and project time. Okay, and I'm not 100% sure what the review is going to look like right this second, but we definitely will be incorporating y'all's study guide if you've seen that. Okay, so that's what we have for the rest of this week. Now, Monday is Monday is pretty important. Okay, and so what we're going to see is that Monday you're going to have your project due, and you're going to have a test, and you're going to have your binder check. Okay, so that seems like a lot. All right, it seems like, ooh, okay, but we're going to talk about that and make sure that we have a decent understanding of it. Okay, and so what we're going to see is the setup is pretty easy for us to understand. We're going to go through and make sure that we have everything done. Okay, and the binder check has already been set up. Okay, but so you can go ahead and start dropping notes and stuff in there if you want. But just once we're done with stuff tomorrow, then you can go through and look at that and set that stuff up and make sure that we have a decent understanding of it. Okay, so we will go through and talk about it, but for the most part, you have the project, okay, the test, the binder, and all that kind of stuff, coming up. Okay, I was going to tell you something about the binder. Oh, the binder check. Okay. It goes against my better judgment for the most part, but what you're going to see is that the binder check, even though it is due um, Monday, okay, it closes on Wednesday. Okay. And so what that means is I'm going to be grading that stuff on Monday. I'm going to be looking at it. I'm going to be, but you have the opportunity, if you turn it in early, to fix something if there is something wrong with it. Okay. And this is not early, this is on time. You have the opportunity to turn that stuff in. And then if there's something messed up with it, then you can fix it. If you turn it in on this date, you get what you get. All right. So it's one of those things that you got to go through and make sure that you understand. Okay. That's kind of where we're at right now. The last thing, progress reports and stuff. Okay. Progress reports are coming out next week. All right. And I have been calling and texting and emailing and all that kind of stuff, parents, and, checking in with them with regards to the stuff that we have to make sure that we have stuff that we have to make sure that we have completed. Okay. So, it's going to be very important to make sure that you have your stuff turned in. Okay. And that your stuff is all set up. Okay. Now, the last thing, let me make sure everybody's attendance is good here. The last thing is, last period, we wound up, and I'm going to be perfectly honest with you, we wound up with like 5 or 6 kids left in class. Okay. And their class is much bigger than y'all's. So it's not like, oh, well, that's how many we have now. If we are not participating in class, if we are not paying attention, answering me in the chat and things like that, you are going to be put in the waiting room. Okay. And then once you're put in the waiting room, if you do not leave and come back, okay, to say, hey, I'm here, you're going to be kicked out and you're going to be marked absent. I don't care. Okay. Because the expectation is that we are paying attention to what we need to do in class. Okay. And you guys have done a pretty decent job of that. Some of y'all get kicked out every once in a while too, but you got to make sure that it's just a non-negotiable. If you're going to be here, you're going to be here. Okay. So, that's just what, I got to say on that stuff. Now, today we're going to finish electron configuration. So we're going to learn a shortcut. Okay. We like shortcuts, especially when we have these big old long electron configuration things. Okay. And then you guys are going to have the opportunity to work on your practice from yesterday. Okay. So I'll tell you what specifically is due. Okay. We're not doing all of it still. We'll finish it tomorrow. Okay. But you're only going to have a certain amount of this stuff for today. So yeah, you do not have a new warm up. Yeah, right. So I didn't put that in there because I had all those announcements and stuff. So that's why, I want to make sure that you guys have enough time, especially considering I spoke most of the day yesterday. Okay. So we're going to go through, we're going to talk about these slides. Okay. It's literally like 2 slides that I'm going to walk you through and make sure that you have an understanding of. And then you guys are going to be working on your stuff. Okay. So that's going to be the main thing. I'll talk about the order of things that you need to work on in a second. So if you look at your stuff that we did yesterday, okay, first of all, yesterday we talked about electron configuration. Okay, and so the steps for electron configuration were given to you. And those steps are very simple, okay? And it's going to just be something where we learn how to do it. As soon as we learn how to do it, we'll be good, okay? So the first step is you have to identify the element. Then you're going to read the periodic table, basically like a book, okay? The last step is you're going to count how many elements you have crossed. Okay, so we'll talk about that today. Okay, yesterday our example was aluminum. Okay, and so what we dealt with and talked about is that you have to go across the periodic table and fill in as you go across. So we talked about the S, P, D, and F block, okay? And then when you go across, you have S, S, okay? So you have 1S, 2S, and that's based on what row you're in. Hey, look at me, I said row, okay? Then you have 2P, 3S, and then 3P. Okay, and if you remember from yesterday, the little numbers at the top are how many spaces you have gone. So you're in 3P and you're in the first space. That's why it's called 3P1. Okay, and so we dealt with the fact that these are very easy. Okay, and we dealt with the fact that once you practice it, you'll get it. But otherwise, it's going to be really hard. Okay, so it's going to be something that we're going to work on for several days. Okay, the other way, all right, that we talked about yesterday was how to figure this out based on what the ending is. Okay, and so we talked about the idea that D, the D orbital, is 1 behind, so it's always 1 minus. So as an example, if you're in the 4th row, you're 3D. 5th row, 4D. 6th row, 5D. It's always 1 behind whatever row you're in. Okay, so if you're in row 5, you automatically know your D is going to be 4. Okay, so this is stuff that's pretty simple. And we talked about the fact that 3D3 is right here, and you go 1, 2, 3. Okay, and that was vanadium yesterday. All right, so that's kind of a review of what we dealt with. Now, we are going to today talk about the noble gas configuration. Okay, the noble gas configuration is a way for us to cheat. Okay, and I see some of y'all's work. Some of y'all like to cheat. Okay, so when we deal with this, all right, you first have to find the element on the periodic table. That step is the same. Okay, however, let's say we're running a race. Okay, and here's your track. Okay, you can find me on Gehringer's track like all the time. I'm constantly out there just running and running and running, and I'm too freaking big to be running. I'm like, But anyway, let's say the starting line is here. Wouldn't you want to start here if you're in a race? Be like, y'all go ahead. Y'all start from over here. I'm going to start from over here and beat y'all. Well, this is basically the same thing that we're doing. So we still have to go down the periodic table and do 4S or 4P or whatever. However, you're basically jumping ahead. So you don't have to write 1S2, 2S2 every single time. All right. So I did not teach this to you yesterday because it would be the only one that you'd want to do. Okay. And sometimes you just need to do the full one. So you go back and you find the noble gas, and then you write the symbol in brackets. So I'm talking about this because I want you guys to make sure that you have this in your notes, but we're going to demonstrate it, and I'm going to visually show it to you in a second as well. Now, once you skip ahead to the noble gas, then you basically continue to do what we've been doing, where we say 4S, 3D, 4P, and you go through. Okay? So when we look at this, all right, iodine is going to be our example. Okay, iodine has over 50 electrons. Okay, so the stuff that we did yesterday, this is how you would write it. You'd go 1S2, 2S2, 2P6, 3S2, you keep going and you keep going and you keep going, and then you finally hit iodine. Okay, well, there is a shortcut. All right, and so when you look at this, you can pick a noble gas. Okay, and one of the things that you guys are going to want to do is pick something other than a noble gas. Well, the reason we pick noble gases is we talked about the fact that they do not trade electrons. They don't gain or they don't lose any electrons. They're always going to have the number of electrons that they have. So argon is always going to have 18. Helium is always going to have 2. Okay, there's no change. All the rest of these elements over here everybody but these guys can lose or gain electrons. So we start here because it's a stable footing. Okay, we don't want to have the if you're standing on a ladder, you don't want the ground to be moving. This is what we're looking at. Okay, so if we're trying to do iodine, we have to pick the noble gas that comes before iodine. Okay, now the other thing that you guys are going to want to do is you're going to want to pick xenon. Well, Mr. Kuhn, xenon's right beside it. Why don't we pick xenon? Because xenon has 54 electrons. You have to account for every electron. Okay, it's like if you babysit. Okay, if you start out with 3 kids, you better end the night with 3 kids. You better find all of them. Electrons are the same way. Okay, so you're going to pick the noble gas that comes before it. Okay, I told second period, if you're a numbers person and you're like, well, is it this one or is it this one? Iodine has 53. You're going to pick something that has the closest amount of electrons without going over. So 36 or 54, you're going to pick 36. Now, so what that means is, hold on, here we go, got it. So what that means is, rather than going, and doing all that, you're literally going to skip it and you're going to start right here. You're going to say, you know what? We know all of those. Because remember, we dealt with the fact that every electron is set up the same way as you go up the periodic table. The only ones that change are the valence. Okay? So when you do this, it circles it. Okay? And all you're going to do is you're going to put that krypton in brackets. Okay? What that means is we know 100 million percent, oops, sorry. We know 100 million percent that krypton is da-da-da-da-da-da-da-da all the way to 4p6. So we get rid of it. We don't need to write all that stuff. It's a shortcut. Okay? So if you start at, erase it. Okay? If you start at krypton, then you just have to go until you hit iodine. Okay? And so in this case, what you're going to do is you start down here at 5s, you go 5s, 2, 4d10, 5p, 1, 2, 3, 4, 5. Okay? We basically skipped ahead and we said this krypton is what we're looking for. And then we're going to jump from there. So it's way easier to do it this way. Now, you do still need to know how to do both. Okay? Because if I just showed you how to do this, you wouldn't get kind of how to do the other one. Okay? But this is something that is going to be helpful for us, especially if we're going to use this type of thing. Now, on your element project, it asks you to do the long hand, okay, which is this, and it asks you to do the noble gas configuration. That's what this is, okay? So now you know how to do that, okay? So each day you can basically go through and do it on your project. You can add a little bit to your project. Now, I'm going to show you how to do these guys down at the bottom, okay? I'm going to show you how to do tungsten, and then you guys are going to do calcium for me, okay? So let's look here, okay? First of all, these down here, you can do these the exact same way, okay? So if you look, ooh, somebody joined us. If you look, okay, the elements from the noble gas configuration, all right, we can do it 2 ways, okay? And I know which way you all are going to want to do. All right, the first one says you start at argon. So argon's right here. And then you go, oops, 4s, 3d, and 4p3. So we know that we're in the 4th row. You're going 4s, 3d, and then you're going 4p, 1, 2, 3. Okay, So if I was to ask you which element that is, which element this is, you would tell me arsenic. Very simple. Okay, so all you got to do is look at 4P. That means you're in the fourth row, the P column. Okay, and if you don't remember, here are the blocks. You got S block, P block, D block, and F block. Okay, pretty simple to go through and remember. Okay, and so that's pretty easy for that one. Let's look at the second one. Okay, the second one is in the third row. So we know that if you have neon, then you're going 3s2. So you're going 3s2, 1, 2, and then you're going 3p3, 1, 2, 3. Okay, the second one would be phosphorus. All right, it's very, very, very easy to do once you understand it. Okay, if you do not understand it, you're going to be looking at it like, ooh. So you have to actively try and make sure that you are getting the information. Okay, and I'll be available to help you. Now, I'm going to do tungsten, and then you guys are going to do calcium. Okay, I'm going to do tungsten, and you guys are going to do calcium. So, tungsten. I don't even know where it is. It's in here somewhere. Hold on. Where are you? I know you're in here somewhere. Where are you? I can't find tungsten. I just found it a second ago. There it is. It used to be wolfram. Okay. So what you're going to do, all right, let me turn it back to the other one. Okay. If you do tungsten the long way, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, blah, 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 blah. You're going to keep going down almost the whole periodic table. Okay. It is not worth it. So the first step is you have to find what noble gas is going to come before tungsten. Tungsten has 74 electrons. So radon wouldn't work. It has more than the electrons that you need. You would have to use xenon. Okay. So if you write xenon in brackets, that basically means that you have not had to do all of this. You have not had to do all of that. We skipped it. Okay. And so that's pretty good for us. I mean, I feel like that's a better setup than having to go through and do all of that. So you have xenon, and then you go 6s12. And if you look at it, okay, this is difficult to do. Okay. But if you look at it, you're going to go 5d, 1, 2, 3, 4. Okay. So what you end up with, whoops, by default. Okay, what you're going to end up with, if you look at it and you do it this way, is not the right answer. Okay, so you got to make sure that you are looking at the fact that F comes in here as well. Wolfram would be really, or excuse me, tungsten would be really difficult to do. Okay, otherwise. So when you do this, pretty self-explanatory. Now, what I want you guys to do is to do calcium. All right, I'm going to give you guys 4.5 minutes like I did yesterday. Okay, and in the chat, I need you to tell me calcium. Okay, calcium. So you're going to find the noble gas configuration of calcium. So I'll set it up to start. Okay, you're going to find a noble gas to put in there, and then you're going to write out the configuration after that. All right, so 4.5 minutes, and go ahead and get started, please. And guys, keep in mind that all participation and all attendance and things like that is dependent on you working with this. An acceptable answer is, hey, I need more. Yeah, I'm not sure where to start. An acceptable answer is, yeah, I think, do you start with it? Ask me a question. All of those are acceptable answers. You got to make sure that you're having an open communication with me. Got about 3 minutes left. All right, you guys, you got about 1 minute and 30 seconds for your response. And again, any sort of response that where you would be asking me a question, okay, where you would be explaining what you're finding as difficulty, okay, and um, or anything like that, okay. All right, if you need a little bit more time, let me know, please. All right, so you're going to see a little bit of a change with regards to the um, way that we have stuff set up. Hold on 1 second. So first off, you will notice that quite a few people are now in the waiting room. Okay, I do. Uh, I'm not sure what the disconnect is with the chemistry classes, but a couple of you guys, when I asked if you had a response, gave me an acceptable response. Okay, like it is okay to say, Mr. Kuhn, I know you are asking me about this. I have no idea. Okay, it is okay to say I I need help. It is okay to say, is this right? Okay, if you have a guest, you remember the chats are going to me privately. Okay, and so I want us to struggle a little bit to get this information, because if you struggle to get information, you will never ever forget it. Okay, and it kind of sucks. All right, and we wish everything would just come to us, but even people that there are people in here that speak 100 languages. Okay, and English is not their best language. They are trying. I don't know, Ms. Kuhn. I need time. Okay, I need time is an acceptable answer. I need help. All acceptable answers. Okay, so these are um, very um, important parts of this, because what's going to happen is that we, like, tomorrow is going to build on this stuff, and yesterday we built on to do today's stuff. Okay, so I have no problem at all. Okay, and like I told y'all, I even warned you. I have no problem at all teaching to 5 or 6 people that are going to do that are really paying attention. Okay, I'd almost rather do that. So for those of you who are still here, good job. Okay, some people are not here, and what you'll notice is they haven't tried to re-enter class. You can always re-enter class if I kick you out. So what that means is they're not even by their computer. You turn on your thing, you come in, you're not paying any attention. Well, I don't have time for it. Okay, so again, good job for you guys. All right, but just don't get caught up in the future, in that sort of situation. That's just going to be what we're dealing with. Okay, now when you look at this, okay, there's only one person that got it right. Okay, and we're not at the test day is Monday. I'm concerned when only one person gets it right on test day. Okay, right now I'm not concerned with that, because you're going to be able to go through and look at it. Okay, so we got to make sure that we're paying attention to that, though. So calcium, if you remember from yesterday, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, however, we know that we can skip a whole bunch of junk, and we are going to skip a whole bunch of junk. Okay, so what we're going to put in there is we're going to stick argon in there, which basically means we are skipping ahead and we're not doing all of this, because argon never changes. Okay, so what we're basically doing is starting from argon. And so what you have to do, the first step is to find the element. The second step is to put the right noble gas into the column, or into the bracket. Okay, this basically means you replaced 1s2, 2s2, 2p6, all that junk. We don't want to do that. Okay, we want to make sure that we are skipping ahead, okay, when we need to. Okay, sometimes you'll have to do the long way, and that's fine, but this is the short way. So if you're to argon, the next level that you have to go is 4S1, 2. That's all you do. So this little spot right here, argon 4S2, okay, that took up the space of all of that junk that we were doing. Okay, so it's a shortcut. All right, it's a shortcut. Now, we didn't have that much new information to do today. Okay, we didn't have that much new information to do today. Okay, however, we are going to go through and you guys are going to make sure that you have an understanding of what you need to do today. Okay, so the tasks that you have for today, I'm going to give you as much time as I can. Okay, but yesterday we started working on this sheet. I got to take this hoodie off. It is 900 degrees in here. Anyway, so yesterday we did only the electron configuration for 1 through 5. Okay, and then we did the electron configuration for 1 through 10. Well, now you still cannot do the orbital diagrams. Okay, you still can't do that. That we're learning tomorrow. So we'll finish this sheet tomorrow. But so the example that I gave, sodium is 1s2, 2s2, 2p6, 3s1. Okay, so this is hopefully what you had for sodium yesterday. Well, now we learned, okay, and obviously I'm writing larger, but you can expand it on your sheet, that you can put neon in here, and then this just go 3s1. Okay, so for number 1, that should be what you have after today. Okay, number 2 would be magnesium. You just keep going on. Okay, if you need help with this, I am here to help you. Okay, now I'm going to be calling parents and people that don't come back in class, and I'm going to have some issues with that. Okay, but this is what you have set up. Now, so, sorry, I had to answer a question. So what we're going to see is that's the first part of the things that we're doing. So 1 through 5, you're doing 2/3 of it. And then 6 through 10, you've already done. Now, 11 through 14, you're going to do the stuff that we did the other day. Okay. And then 15, you're going to do the stuff we did today. Okay. So all you're going to do is say, what is 5F11? Okay. So that's going to be in the 7th row, and you'll have to go over and count that. Okay. That one is a little bit hard. But then 16 and 17 are really important. I told you that you're going to get some stuff wrong, and why you're going to get it wrong. You have to tell me why 16 and 17 are wrong. Okay? I don't want, let's say this is oxygen. It's not. But I don't want you to put oxygen here. I want you to put the 2s is in wrong place, or something like that. What's wrong with how it is written? Okay, for 16 and 17. Then you have 18, 19, 20, and 21. We are stopping at 21. 1 through 21, no orbital diagrams. Whoops. You don't know how to do the orbital diagrams yet, so don't be Googling stuff. Don't be Googling stuff. Stop it. I'm doing the clapping thing again. Okay? This part, the shorthand, that's where you use your brackets, where you cheat. Okay? I'm telling y'all to cheat, but don't cheat by Googling stuff. Cheat by Googling how to do it. That's the difference. Learn how to do it. Okay? Google is a tool. But what's going to happen is if we just say, hey, how do you do noble gas configuration for xenon? Okay. Well, we're not going to be able to do it. And then tomorrow, next day, the next day, the next day, we're not going to be able to build on those skills. Okay. So let's make sure that we do this right. Okay. element project, okay? Today's sheet, which is 1 through 21, or anything that is old that you owe me, okay? And I'm gonna be here after I take this hoodie off because I'm in here sweating, okay? To help you guys out with anything that you need, okay? Anything that you need. Let's go ahead and get started.